Welcome to this module of Professor Messer's free CompTIA Network Plus certification training course, the online training course for people that watch online training courses. I'm James Messer, and in this module we're going to discuss common application layer protocols. And as crazy as it looks on the screen with all these abbreviations from our section N10-004 section 1.1, we really are going to explain the function of these application layer protocols. Now you'll notice there's a lot of abbreviations here. A number of these protocols we've already discussed in our previous module that is a part 1 on link, internet, and transport layer protocols. In this particular module, we're going to focus only on the application layer protocols, and there's quite a few we're going to go through. If you recall our Internet Protocol Suite from our last video, I organized this big grouping of all of these jumbled letters into these different categorizations, and this follows our Internet Protocol Suite at the link layer, the internet layer, and the transport layer. So this module, we're going to focus solely on all of these different protocols that happen to be right up here at the top at our application layer. There's quite a few application layer protocols to look at. What we've really tried to do is separate each one of those protocols that we have at that layer into different categories. And so what I did was break these out into management protocols, remote communication protocols, file transfer protocols, mail protocols, browser protocols, and voice over IP. And in each one of these categories, there are different protocols in use. We're going to step through every single one of these. So at the end of this, you'll not only know what that protocol does, you'll know, oh, that's for browsers, or that one's for voice over IP. And they'll really help you when you start working on the Network Plus exam and you're presented with, what is TFTP? Well, it's used for files. And that might help you get through that particular question on the exam. Let's begin with management protocols. The first one we're going to look at is a little bit of an older protocol, but we see it from time to time, something called BootP, and it's called the Bootstrap protocol. BootP was the first method that our computers ever used to automate the process of getting an IP address. If you've probably worked on your computers before you've plugged into your network and you were on the internet, you didn't have to customize or put any IP addresses into your computer. It was all done automatically. These days, that's probably done by a protocol called DHCP, which stands for the Dynamic Host Configuration Protocol, which is really the next generation of BootP. Sometimes we even call DHCP the BootP process. They're almost used interchangeably because they are just very, very similar to each other in the way that they operate. So if you've ever tried to figure out how did I automatically get an IP address, it was probably this BootP or really ultimately this DHCP that did that for you. Another management protocol is one called DNS here at the application layer. That stands for Domain Name Services. And DNS is extremely useful because when you start working in DNS, you don't know the IP address of Google. You don't know the IP address of Yahoo. You don't know the IP address of ESPN.com. You simply type into your browser google.com and magically that Google screen appears right here on your browser, but you didn't know the IP address. Behind the scenes, DNS has asked for you, does anybody know where google.com is? And the DNS server says, oh yes, when you need to go to google.com, you need to go to this particular IP address. And that's how your computer ultimately knows how to get out to those particular services. DNS is extremely useful because now we don't have to memorize IP addresses. Think of how that would be if you had to know every IP address you went to over the internet. Being able to type google.com, much simpler to do. And the last management protocol we'll look at is called NTP, or Network Time Protocol. This is really useful when you need to coordinate clocks against different devices on your network. You want every server to be at the same time, every router that you have at the same time, every switch, every firewall. And you can set in your workstation something called the Network Time Protocol so that everything is synchronized. For instance, here from my Windows machine, I can configure my time settings to go out to a particular server. time.apple.com, time.windows.com, time.nist.gov. Go out to one of those time servers and synchronize up so that I'm running at the same time as everybody else happens to be running. There's one more big management protocol. Almost forgot about this one, SNMP. That SNMP is the Simple Network Management Protocol, and there are different versions of SNMP. They're all essentially doing exactly the same thing, but there's a different way that they work under the surface. SNMP is most often used to gather statistics from network devices. So if you're somebody who's responsible for checking the uptime and the performance of a router or a switch or a server, you can use an application that uses SNMP to communicate to these devices. And the routers and the switches and the servers, of course, have to know how to to respond to SNMP requests. The Simple Network Management Protocol version 1 was the original, and it uses something called a structured table. In that way, you can ask for very common things from devices, and those devices know to send you back very common responses. For instance, you can say, how many bytes have gone into this particular interface on the router, and the router will respond with a number back. Every device you talk to where you say how many bytes going in, it knows what you're referring to. It doesn't really ask how many bytes in. There's actually a numbered string that's used there. And every device knows what numbers to expect and the response that should go back from those. Now, SNMP version 1 was extremely useful, but it passes this information in the clear. It's not encrypted. Anybody who happens to be on the network monitoring these links can see that information. From a security perspective, probably not what you want. So we created a new version called SNMP version 2, where I can really now do bulk data. I can ask for multiple things at one time and get multiple answers at one time. So the efficiency of communication was improved. It also improved the type of data that I'm able to get. However, it didn't improve the in the clear problem. I still had this data that was not encrypted going back and forth. The latest version of SNMP is SNMP version 3. And version 3 is the latest standard, and it added a number of capabilities primarily from a security perspective. The first thing it did was add message integrity. When we receive an SNMP response, we know that the data within that packet was not modified. What was sent was actually what was received. We also know that it's authenticated. We know when we receive the data, we can do a check and make sure that the data that we received really did come from the person that we asked. Nobody modified it in the middle. It wasn't returned to us from another device that we weren't expecting. Really is authenticated. And perhaps even more importantly, the data can be encrypted so that as we receive all of this really important management data across our network, somebody might be able to go into the middle and grab that data, but they won't be able to make heads or tails of it. Completely encrypted. The only people that are going to be able to read that is the workstation that receives it on the far end, the one that's designed to receive that management data. So much more secure, and in very large enterprise environments, they really like to use that SNMP version 3 primarily for those security reasons. We have another category of remote communication protocols. And remote communication protocols allow us to communicate out to other devices and receive information about what's going on out there. And if you're somebody working on a network, you may have tens or hundreds or thousands of devices over the network. You want to be able to sit at your desk and be able to communicate and manage any of those. One common protocol that's used for that is something called Telnet, which stands for Telecommunication Network. That allows us to access devices remotely. The issue with Telnet, and the reason you don't see it used very much anymore, is that it is completely unencrypted. There is no ability to encrypt any of the data in there. So you really don't see this in large environments. You really don't see it in small environments these days either. It's definitely not your first choice. And although it may have capabilities to be turned on many of your devices, most security people and most network people recommend that you don't use Telnet if you're at all concerned about the security on your network. A better way to do this is something called SSH. SSH stands for Secure Shell, and that's really what most people, most networking professionals use to be able to communicate out to those other devices. It looks the same as using a Telnet. It gives you the same interface as Telnet, but the communication between your device and the device on the other end is completely encrypted, so that if anybody did tap into that connection, they would not be able to see your username. They would not be able to see your password. They would not be able to understand anything that you happen to be doing on that network because it is completely encrypted between those two devices. We move files quite a bit on our network, and so there are application protocols that are specifically designed for transferring files. One very common one is called FTP, which stands for File Transfer Protocol. This allows us to take a file that's on our machine and transfer it to another device. So this isn't that terminal screen where we're typing in commands. We're actually taking an entire file and transferring it across to another device. And FTP requires that there's a username, that there's a password, there's an authentication method that's used when you send that packet and all of those files to another device. There's a lot of functionality in FTP. I can list what's on a directory on the other side. I can add files, I can delete files, I can rename files. It's all built into this really comprehensive file transfer protocol application protocol. There's another file transfer protocol called TFTP, which is Trivial File Transfer Protocol. And just like the name implies, it's a much simpler way of transferring files back and forth. First, it only allows me to read and write files. That's it. I can't do a lot of management capabilities with TFTP, and there is no authentication for FTP. There's no username and no password. You really can transfer files willy-nilly back and forth between those. You really don't see this used much on production systems because you don't want people transferring files back and forth with no authentication. You would like everything to be done all with some management, some authentication, and some security involved on the back end. If you've ever used file transfer protocols either at the command line or in a graphical environment, here's a really good example. You have all of your files on your side, on your machine, and can simply drag them and drop them into some directories on the other device on the other side. So whether you're working in a command line or a graphical mode like this, behind the scenes, it's still using the file transfer protocol. And if you look here at the top, you can see some status commands, some commands, and some responses. Those are the FTP commands going back and forth. And it's really just put them up here into a human readable form so we can watch what's happening as FTP uses its management protocol back and forth to transfer those files. Where would we be if we did not have our mail? But the mail itself uses a number of application protocols to be able to send our email back and forth between devices. The one that's commonly used for transferring files from one device to another, one server to another, is something called the Simple Mail Transfer Protocol. And this is between mail servers. We don't often see this at the workstation level. When we send mail, our mail server needs to communicate to another mail server, and it uses SMTP to be able to do that. We have a protocol that's used on our workstation. When we need to get our mail from our mail server, we use something called the Post Office Protocol. And the latest version of the Post Office Protocol, or the most common one that we use, is POP3, Post Office Protocol version 3. What we really do is connect to our mail server. We say, please download all of the latest mail to us. I'll store it locally here on my machine, and then I'll disconnect. Really great if you're remote, if you need intermittent connectivity to your mail server. It's really designed for simple retrieval of mail, pull it down, and have it local on my machine. These days, we almost need a more centralized way to work, though. And so another mail protocol is called IMAP4, the Internet Message Access Protocol version 4. Now, POP3 may be more popular, but IMAP is certainly more functional. It allows for flexibility and connectivity, and it keeps state in our mail. We can keep our mail centralized on a server and simply use IMAP to read the mail, set it as read, set it as unread, reply to mail. I can then go to another machine, another device, and connect to that same IMAP, and I can see the state of all of my mail. It's exactly the way I left it. I don't have to have one central database that has to follow me around everywhere I go. And that's why you'll notice a lot of internet protocol, internet management devices, internet service providers, they will use IMAP because it just extends and is much more functional, much more flexible than using something like POP3. If you're configuring the mail on your machine, for instance in Thunderbird, here's a good example. It says select the type of incoming server you're using. Are you going to be using a POP server, or are you going to be using an IMAP server? So you're going to want to ask your mail provider, your internet service provider, whoever you get mail from, can this do POP or does this do IMAP? Or do I have a choice? Can I use either? And you may want to decide to choose IMAP over POP3. But that's exactly where you'd see those protocol names pop up. And the SMTP server, when you're ready to send data to a mail server or send data between mail servers, you're going to want to put in SMTP server information. What is the name of that server? What IP address is it located on? What port number does it use? Do you need to authenticate to be able to send mail out? So very often you're using POP and IMAP to receive. You're almost always using SMTP to send, and almost always using SMTP to send between mail servers themselves. Our browsers provide us with a lot of different capabilities, but to be able to do that, they also need to have a lot of different protocols that they use. One of the most common is HTTP. HTTP is the fundamental browser protocol used on this internet thing that you may have heard of. This HTTP protocol is really not just used by browsers, but many different applications, primarily because it's so common. It's really an extremely well-known application. And in many cases, you know that HTTP, that particular application protocol, will get between point A and point B. So even if your application you're using isn't a browser, under the surface, it may be using the HTTP protocol to be able to send traffic back and forth. Now, to be able to do that and be secure, We also created another protocol called HTTPS, which is our Hypertext Transfer Protocol Secure, which adds an extra bit of encryption to the data. So if you're ordering a pizza online, they ask for a credit card. You're on Amazon buying a book and it asks for a credit card, and you get that little lock at the bottom of your browser. That's because it's using HTTPS, and now you know that all the data you're sending back and forth is going to be encrypted, and it's using HTTPS to be able to do that. Within HTTPS, it's using a set of encryption protocols, what we used to call SSL, which is now called TLS, or Transport Layer Security. SSL is referred to as Secure Sockets Layer. SSL was the original version of this. It was created by Netscape many years ago, and it was updated into a more robust and a better version called TLS. We still many times call it SSL. It's very common to just call it SSL. I think it just rolls off the tongue. But in reality, the protocol that's really used to do this these days is TLS. So if you see TLS in your browser configuration, don't be thrown by that. It's really referring to that encryption, that SSL type of protocol. The last couple protocols we're going to want to know about for our Network Plus certification are these voice over IP protocols. Voice over IP obviously becoming extremely popular, whether you do voice over IP and instant messaging, whether you use Skype, or whether you use a voice over IP phone on your desk. The way that these devices communicate back and forth to each other at a management layer, the way that they set up the phone calls, the way that they communicate signaling back and forth to each other is through generally a protocol called SIP, or Session Initiation Protocol. We call this a signaling protocol because it's in charge behind the scenes to set up calls, to tear down calls, to provide management information between devices. And so SIP is extremely important. You never see SIP. You don't understand that as a human being. You don't even really interact with SIP. SIP's in charge of the phone devices communicating amongst each other. But it's a very common protocol. If you were to capture the packets that were going back and forth from your voice over IP phone out, you would certainly see a lot of SIP traffic in there. The primary amount of traffic that you're going to see, though, is something called RTP, or Real-Time Transport Protocol. These are the actual packets that contain the media that is being sent back and forth. So the voice within your voice over IP call, or the video that's being used with this voice over IP set of protocols, really going back and forth over something called RTP. If you're doing packet capture, you'll see a little bit of SIP, and then you'll see a lot of RTP after that, and you'll see some more SIP intermixed within the RTP to make sure the call is continuing. And at the end of the call, SIP breaks down the call, and you don't see any more RTP. So very simple to use on the networks, very simplified process to go back and forth, but you really need a management protocol in SIP, and you really need a way to transfer the protocols with RTP. Let's review some of these common application layer protocols. Our first question is, what application layer protocol facilitates a very basic reading and writing of files to a remote device? And I think our keyword in this particular example is very basic. If you recall, there was a trivial file transfer protocol, or something we call TFTP. Our next question, which voice over IP protocol carries the media stream? If you recall, there was one that managed the tear up, the breakup of the call. Our next question, what voice over IP protocol carries the media stream? If you recall, there was one management protocol that handled creating and tearing down those, and another one that actually carried the data, and that was the Real-Time Transfer Protocol, or Transport Protocol, or RTP. And the last question, what application layer protocol securely gathers statistics from remote devices, primarily for management purposes? Very simple protocol called Simple Network Management Protocol version 3. And that's the one that really gets that secure piece in that question, adds that authentication and integrity and the encryption to the SNMP communication. Well, that covers everything we need to know about our common application layer protocols. We've taken all those crazy acronyms. Now you should have a pretty good idea of exactly what all of these things do. If you'd like to see any of our other Network Plus videos, you want to participate in our message boards and much more, you can always visit our website. Head out there to freenetworkplus.com.